In this video, we're going to learn how to multiply and divide with the numbers that are written in standard form. We might recall that a number written in standard form looks like 3.6 times 10 to the power of 6, or 1.207 times 10 to the power of negative 2. The first part of numbers written in standard form is a number that will be greater than or equal to 1 and less than 10. Then we will always multiply this by 10 to the power of something, and that power or that index will be a whole number. And if we're working with a positive power, that tells us we have a very large number, whilst the negative power tells us we have a very small number, a number less than 1. We can convert from standard form into an ordinary number by simply evaluating the calculation. So take 3.6 times 10 to the power of 6, for instance. 10 to the 6th power is 10 times 10 times 10 times 10 times 10 times 10, which is the same as 1 million. So this is actually 3.6 times 1 million, which is equal to 3,600,000. Similarly, let's look at 1.207 times 10 to the power of negative 2. 10 to the power of negative 2 is the same as 1 over 10 squared. So we're going to be multiplying 1.207 by 1 over 10 squared, or 1 over 100. This is the same as dividing 1.207 by 10 once and then twice, which gives us 0.01207. And so one method we have to multiply or divide with the numbers written in standard form is to simply convert them into ordinary numbers and then deal with those. But there is another method, and that involves taking advantage of what we already know about powers. So let's have a look at a couple of examples. We'll begin by looking at a multiplication example. We're going to evaluate, which just simply means find the value of 4.2 times 10 to the power of 6 times 2 times 10 squared. Now, the first method we have for multiplying numbers in standard form is to begin by converting them to ordinary numbers. So let's take 4.2 times 10 to the power of 6. That's the same as multiplying 4.2 by 10 6 times. And what happens is we move all the digits to the left 6 places. And when we do, we see that 4.2 times 10 to the power of 6 is equal to 4,200,000. Then we take 2 times 10 squared. That's the same as multiplying 2 by 10 twice. So we're going to move the digits to the left 2 spaces. And so we get that 2 times 10 squared is equal to 200. This in turn means that the calculation 4.2 times 10 to the power of 6 times 2 times 10 squared is 4,200,000 times 200. And of course, to evaluate this, we can begin by simply multiplying 42 by 2 to get us 84. And then we spot that 4,200,000 is 100,000 times bigger than 42, and 200 is 100 times bigger than 2. This means our solution is going to be 10 million times bigger than 84, and that gives us 840 million. But we did say there was a second method here, and this involves using what we already know about powers, about the laws of indices. We begin here by recalling that multiplication is what we call commutative. That means it can be done in any order. And so we can rewrite our calculation as 4.2 times 2 times 10 to the 6th power times 10 squared. And then we're going to evaluate everything inside each set of brackets. 4.2 times 2 is 8.4. And then when we multiply two numbers whose bases, that's the big number, are the same, we simply add their powers. So we get 10 to the power of 6 plus 2, which is 8. And so 4.2 times 10 to the power of 6 times 2 times 10 squared is the same as 8.4 times 10 to the power of 8, which we once again can write as 840 million. Essentially, we move all the digits to the left in the number 8.4 8 times. Now, either method is perfectly valid, but if working without a calculator, method 2 can be a little bit more straightforward. We're now going to consider a second example where we use method 2. Where we use the laws of indices to evaluate a multiplication problem involving numbers in standard form. Evaluate 4 times 10 to the 4th power cubed. We know that one method we have here is to work out what 4 times 10 to the 4th power is as an ordinary number and then cube it. But of course we can also use the laws of indices to help us simplify this problem somewhat. One of the laws of indices that we have involves working with numbers in brackets. So x to the power of a to the power of b is the same as x to the power of a times b. Essentially we just multiply the powers or the indices. And so we can absolutely apply this idea to the problem we've got, and we'd have 10 to the 4th power cubed, so we'd multiply the 4 and the 3. We do of course need to make sure that we also cube the other number in our brackets, the number 4. And so a middle step here to evaluating this problem is to write 4 cubed times 10 to the power of 4 times 3. But of course 4 cubed is 64 and 4 times 3 is 12, so we get 64 times 10 to the 12th power. Notice that since 64 is much larger than 10, this number isn't actually in standard form. But it doesn't really matter since we're looking to evaluate it. So we're going to work out what 64 times 10 to the power of 12 is. And of course, to multiply by 10 to the power of 12, we multiply it by 10 12 times. Essentially, we move all the digits in the number 64 to the left 12 spaces. And when we do, we get this rather nasty looking number, which we can read as 64 million million. Let's now have a look at how we might apply this idea to dividing numbers written in standard form. We're now going to calculate 3 times 10 to the 6th power over 1.5 times 10 to the 4th power, and this is asking us to leave our answer in standard form. Now, of course, one technique we have is to begin by converting each part of our calculation to an ordinary number. 3 times 10 to the 6th power is found by multiplying 3 by 10 6 times. In other words, we move the digits to the left 6 places and we get 3 million. Similarly, we need to multiply 1.5 by 10 4 times, moving the digits to the left 4 places to get 15,000. And so our calculation becomes 3 million divided by 15,000. Then we can kind of simplify this calculation somewhat by dividing by 10 once, twice, and then a third time. This leaves us to calculate 3,000 divided by 15. Well, 30 divided by 15 is 2, so 3,000 divided by 15 must be 200. But of course this question told us to give our answer in standard form, so we have to convert it back, and 200 is 2 times 10 squared. Let's look at the alternative method, and that is to use our laws of indices. We might remember that to divide something like 10 to the power of 6 by 10 to the power of 4, we simply subtract the powers, and we're able to do this because the base, the big number, is 10 in both cases, it's the same. So let's work out what 3 divided by 1.5 is. 3 divided by 1.5 is 2. Then when we subtract the powers, we get 6 minus 4, which is 2. And so we see that 3 times 10 to the power of 6 over or divided by 1.5 times 10 to the power of 4 is 2 times 10 squared. Once again, either technique here is perfectly valid, but we can see quite easily here that method 2 saves us a lot of time. Let's have a look at one more example. Calculate 1.4 times 10 to the 5th power over 2 times 10 cubed, leaving your answer in standard form. Now we know that one technique we have is to evaluate 1.4 times 10 to the 5th power and then work out what 2 times 10 cubed is as an ordinary number and then divide from there. But there is a quicker way. We know that we can divide two numbers whose bases are the same, that is, the bigger number is the same, by simply subtracting their exponents or their powers. And so let's work out each part individually. We're going to work out 1.4 divided by 2 first. 1.4 divided by 2 is 0.7. Then 10 to the power of 5 divided by 10 cubed is 10 to the power of 5 minus 3, which is simply 2. And so 1.4 times 10 to the power of 5 divided by 2 times 10 cubed is 0.7 times 10 squared. But of course this isn't actually in standard form, since 0.7 is less than 1. So how do we convert it into standard form? Well, we need to make the first part of the calculation 10 times larger, and then this number 7 is indeed between 1 and 10. Now, in fact, to do this, we had to essentially borrow a 10 from the 10 squared, and so we're going to reduce the power of 10 by 1. And we see that 1.4 times 10 to the power of 5 over 2 times 10 cubed is 7 times 10 to the power of 1, or simply 7 times 10.